Well, let us begin with a quick review. In part 1, we looked at some bad definitions of science. You could call these naive definitions. Science is what the scientific community says it is. Well, what if you're doing science and no one knows about it until you publish? Science is careful and precise. Well, not everything careful and precise is science. Science is humanity at its best, except when science is humanity at its worst. Science explains the world with mechanical causes, except then Isaac Newton, not always a scientist. Science is true, unless it's not. So then in part 2, we looked at more bad definitions of science. This time, however, we tweaked 3 of them. Scientific theories, according to Karl Popper, aren't proved true, they are proven false. Science, according to Hempel, doesn't allow us to possibly make connections. It insists on specific connections. And science, according to John Stuart Mill and other people on the positivist side of the spectrum, isn't about explanations. No, it's just about summarizing observations. That's all it can do. Then we looked at that debate, the realism versus positivism debate. And again, I don't agree or understand everything on this diagram. Look it up for yourself. It's just here to help us think about a discussion we could have, and not the only discussion we could have about science. That's what part 2 was all about. So now that we've convinced ourselves that we might not really be able to, quote, know anything, let's remember that we really do know quite a lot, and we can have confidence in this knowledge. Maybe not absolute confidence, but I'll make a bet with anyone that the sun will come up tomorrow. So with all due apologies to Karl Popper, scientific theories really can be proved right. Eddington proved Einstein's equation right. And if you want to insist that, quote, they're not absolutely right, they must remain open to correction when further data is made available, okay, fine. But now you're being just as silly as that person who didn't believe in temperature. So let's take a closer look at what it means to be proved right. But first, a game. Pick a card. But before you do, I have a theory. Would you like to hear my theory? My theory is that somebody has been messing around with this deck. They have replaced all the black cards. All the spades and the clubs have been taken out and replaced with red cards, more hearts and more diamonds. It's an all-red deck. Get it? So, you look at me, kind of give me a funny look there, and then you pick a card. Proof! My theory is correct. Proof! Well, maybe it could be proof, but it also could be a totally normal deck. I had a 1 out of 2 shot of pulling a red card from a totally normal deck, so what should we conclude? Well, I know. Let's pull another card. More proof! More proof. Well, again, maybe, but I'd have a 1 in 4 shot of pulling 2 random red cards out of a normal deck. I still think that there's a chance that the next card I pick up could be black. I have not disproved your theory, that's true, but I am not totally convinced it's true either. And that's the point I'm trying to get at here. No one said we needed absolute proof, just convincing arguments. And some arguments are more convincing than others. But why? Well, before we answer that question, new game, new deck, new game. Well, it's the same game, but it's a totally new deck because I'm going to ask you to do the same thing. Pick a card. But before you do, I have a theory. And this is the last theory about cards, I promise. So my theory is that someone has gone through and made an even stranger trick deck than last time. All 52 cards are the same. They are all the same. They are all the ace of clubs. This person, way too much time on their hands. They bought 52 decks. They took out the ace of clubs from each one of those decks and made a trick deck. Now, you look at me even funnier this time. And then, okay, you draw a card. Bam. Proof. No, that's not absolute proof, but it's better proof. The prediction was more specific. Precision matters. Precision, after all, gave us Argon. And the result was more surprising. Yeah, it still could be a normal deck and you got lucky. But what are the chances of that? Well, the chances are 1 in 52. That's statistics. This is Bayesian statistics, and you can read about the details on your own. Here's the deal. We are keeping the baby and throwing out the bathwater. Scientific proof can be useful without delivering or even promising to deliver absolute knowledge. Even if you had picked 51 ace of clubs, it's still possible that the very last card wouldn't be the same. That's possible, and no one's saying you need to know absolutely. Why? Because science is not just a historical thing, it's also a human thing. And humans don't think in absolutely rigid categories. It's like the deck of cards. Run up to someone and say, this deck has all red cards in it. Do you believe me? And they'll look at you funny and then they'll say, well, maybe, sure. I mean, there's a bunch of different possibilities. Maybe you toyed with the deck. Maybe you wanted to make the deck all red and then you really tried to, but you messed up. Maybe the deck only has 51 cards. Maybe it's a normal deck. Maybe you are a nutball. I don't know, and I honestly, truly, sincerely, with all my heart, don't care. But if you want to show me a trick, I guess I'll humor you, and let's see how good the trick is. And the same thing's true for Newton's gravity and Einstein's relativity. I'm not sure I believe you. I am skeptical, just like the chicken. It's a skeptical chicken by nature. The chicken should have been more skeptical. But if you show me a trick, pull an ace, you'll get my attention. As an aside, if people don't believe in a scientific theory, don't just assume that it's because those people are stupid or because they are brainwashed. People, like chickens, are allowed to be skeptical. If your theory is as wonderful as you seem to think it is, please dazzle us. Please dazzle us. We're ready to see a trick. Be precise. Tell us exactly when that comet or that eclipse will happen. Be surprising. Surprise us. Pull an ace. You'll get people's attention. So far, we have nitpicked our way out of the first 4 statements, but I'm a little bit nervous here. How can you disagree with this last one? Obviously, you have to agree that scientific knowledge grows, unless maybe it doesn't. We need more memes. I refuted logical positivism with a thermometer. Thomas Kuhn apparently annihilates it, at least according to this meme, and he does so with his famous paradigm shift. New ways of looking at things. Scientific knowledge does not just inch forward, it jumps and leaps, probably. The best example of this kind of jump or this kind of, quote, revolution, pardon the pun again, is the paradigm shift from a geocentric to a heliocentric view of astronomy. Now, in order to talk about daily or yearly changes to stars or planets, you would have to have an overall picture of what's really going on. There's a couple you could choose from here. And the point we're trying to make isn't that the one on the left is wrong and the one on the right is correct. It's not about that. The point we're trying to make is that you cannot work slowly and incrementally from the one on the left and get to the one on the right. You have to smash it and start over. Or consider other examples, the four humors theory of medieval medicine, or the modern understanding of the organ system. Everybody knows about blood. Obviously, one system worries about your blood being too caloric. The other one worries about your cholesterol. Totally different questions, totally different understanding. They didn't even know that blood circulates through the heart and stuff like that back in the Middle Ages. Different models, different explanations, different views about what is, quote, really happening. What could a phrenologist and a psychoanalyst say to each other about a patient? How could they even talk to each other fruitfully about this patient? Now, of course, scientists don't spend all their time smashing worldviews. It would be kind of cool if they did, but they don't, and Kuhn didn't say that they did. Most of their daily activities was what Kuhn would call, and did call, normal science. That's his word for it, normal science. Still, paradigms, like pants, wear out. People before Kuhn obviously knew that theories changed. Everyone knew that. Kuhn's contribution was that normal science does not / cannot confirm or destroy the paradigm in which it is performed. We all just kind of have to pick a worldview and go with it. And this is how Kuhn defeated logical positivism, at least according to this meme, because the logical positivists, their dream was a completely objective, completely theory-free measurement. Can't happen. So, science does not grow bit by bit. But what should we say about it? Should we say that scientific knowledge simply changes, that there are different ways of viewing the solar system or the organs in the body? That would be a very value-free way to say it, and somebody would appreciate that. But scientific knowledge doesn't just change, it really does advance. We really know more than we did before. Even if this growth in knowledge is uneven, it does move forward. Again, how you want to think about this, how you want to think about Kuhn's paradigm shifts, it depends on how you want to think about it. This chart puts Kuhn on the right side, which is fine with me, but that doesn't mean I have to disagree with him just because I place myself on the left. I think Kuhn's approach is very interesting, but that does not mean any of us are under an obligation to adopt a radical version of his theory. And in his book, The Structure of Scientific Revolutions, Kuhn is a little bit coy about just how radical a view we can or should or he would want us to take. And by the way, can a geocentrist and a heliocentrist talk to each other? Well, turns out that's a historical, and the answer is yes. Yes, they can, and they did. They can, and they did meet in order to discuss reforming the calendar. They didn't just spend the entire time trying to argue about that. They had a practical question to solve. They wanted to reform the calendar, and they all agreed. They agreed on the importance of precise measurements for the length of the lunar and solar cycles. So there really are things that can be talked about and agreed about, even if we have different paradigms, even if we're arguing from different premises, even if we're just doing something strange like talking about baseball. So where are we? We are right back where we started from, with absolutely no progress made towards trying to define science. In this video, we've mentioned that science looks for convincing, not necessarily certain answers, and that science can grow in an uneven way. So what is science? Well, I've been dropping hints throughout these 3 videos. Time to unveil the big finish here. What is science? Well, what are the hints? Well, science is like baseball. Science is like baseball in that it is a cultural activity. It is an activity performed within a cultural context. Did you do your homework? Did you do your homework? I told you about your homework. I told you to look up the Terracotta Army. I wonder if anyone did. If you did, you would find out that that obviously was a huge organized undertaking. Obviously great skill. Obviously great precision. Obviously great care. Obviously great technological knowledge. So when I would claim that that was not a scientific undertaking, I'm not saying that it wasn't smart. That's the problem when we use the word science. Sometimes we think, well, science is true or science is smart. Well, though the people who put together the Terracotta Army, they obviously knew what they were doing. But does that make it science, or does science exist in a particular social and historical and cultural context? Because what happened to the technicians and the artists that set up that army? They did not retire to endowed chairs of science in university systems. No, they didn't. They didn't have that sort of thing. But that's what Western Europe did have. And it had that not by accident. It had that because of this guy again, Prometheus, with the idea that human reason can attack the chaos, can attack the mystery of nature. But that's only one of the 2 pillars on which Western civilization was built. There's also another pillar. In the beginning was the Word, and the Word was with God, and the Word was God. The same was in the beginning with God. All things were made by Him, and without Him was not anything made that was made. Reading, of course, from the Bible, from John's Gospel, chapter 1, verse 1. That's the other pillar. That's the missing piece. That's the view that not only can human reason attack these mysteries, but there's something worth attacking, that there's something in nature, something worth studying, something good, something powerful, something beautiful just lies in front of us, hidden, yet accessible to reason, there to be discovered. And there's a term for that: organized pursuit, because it is a group project. And that pursuit of seeking, as Bukowski said, the hidden potentials in nature, that pursuit is called science.